Hello geometry students, Mr. Guzzato. Today's learning target is to talk about special parallelograms. So on page 10, you will see the 5 properties of parallelograms. And the learning target today is to talk about the properties of rectangles, rhombuses, or rhombi, and squares. So if you know any of the properties of a rectangle or rhombus on page 10, go ahead and fill those out. If not, we're going to take a look at each of those properties and fill it out together. So let's take a look at a rectangle. So on the screen you will see a rectangle, and if I were to drag the point, you will notice that there are always 4 right angles. So in a rectangle, one of the properties is there are 4 right angles. The second property is related to diagonals. So if I draw in the diagonals here, what do you notice? So you'll see that each piece is 8.86. If I were to change the rectangle, you'll notice now each piece is 6.46 and 9.03. So all 4 pieces of the diagonals are congruent. So if we go back to our notes page, which is page 10, the special properties of a rectangle, so I'm going to label this rectangle, is you have 4 right angles. The second property is the diagonals are congruent. So again, it gets all of the properties of the parallelogram. In addition, it gets these 2 properties. This third bullet should not be there. Let's take a look at a rhombus. If we take a look at the rhombus that is on the screen, and I were to add the dimensions, you should notice that all 4 sides here are 7.6. If I were to drag the rhombus and make it larger, now each side is 9.74. So a special property of a rhombus is all 4 sides are equal. Let's take a look at another property. I'm going to draw the diagonals. First, before I do that, let me show the angles. So just to convince you that the properties of a parallelogram hold true, notice the opposite angles are congruent and consecutive angles are still supplementary. Let's take a look at the diagonals. So the diagonals, if you take a look at the diagonals, are still being bisected. So that property of parallelograms still holds true. Now let's add some angles in here. A special property of the rhombus is, notice the diagonals inside where they intersect always form a 90-degree angle. So we say the diagonals are perpendicular. The second thing I want you to notice is look at angle A. Notice that each angle is 24.7. Look at angle C. Each angle is 65.3. So the diagonals also bisect the angle. So that is a special property of rhombuses or rhombi. So let's summarize that in our notes packet. So I'm going to label this rhombus. So the special properties of a rhombus is all 4 sides are equal. All 4 sides are congruent. The second property that we saw is the diagonals are perpendicular. And the third property we saw is the diagonals bisect the angles. And then the next question is, what will happen if you combine a rectangle and a rhombus? I tend to think of a rhombus as a tilted square. If you want, in the rectangles, we could add this little box, we could add the right angles. I'm not going to try to draw in the diagonals of a rectangle, but maybe I'll draw this one down here to show that the diagonals are congruent. You'll often see the same tick mark here. And then for the rhombus, again, it's a little tight here, but all four sides are equal. I'll add these tick marks. And maybe for a rhombus, let's draw a small rhombus up here. I'll draw the diagonals, because we saw this in the screen that I showed you. Let's put the right angles in where the diagonals are. And let's add one tick mark, one tick mark, one tick mark, one tick mark, two tick marks, two tick marks, two tick marks, two tick marks. So let's go back to the question. If you were to combine a rectangle and a rhombus, meaning you have four right angles and four equal sides, we get a square. So let's scroll down a little bit. So for a square, when you combine a rectangle and a rhombus, you get a square. So I'm going to label this a square. And a square has lots of properties. It has four right angles. It has four congruent sides. The diagonals bisect each other and are congruent. So I'm just going to say the diagonals are congruent because that's like a rectangle. The diagonals are perpendicular. And then the diagonals still bisect each other. So I'm going to label this. We got the right angle here. So we have four right angles. We have four equal sides. So one tick mark there. If we were to draw in the diagonals here in green, those diagonals are congruent. So I'm going to put two tick marks on each of them. The diagonals are perpendicular, so I'm going to put the boxes, the right angle symbol in the middle. And the diagonals also bisect the angle. And since the angles are 90 degrees, each angle here, as a result, is 45 degrees. So this is sometimes called the quadrilateral family tree. And we're going to start taking a look at some practice problems in a minute. On page 11, you will see a rhombus, a rectangle, and a square. See if you can recall the different properties of each shape without looking back at your notes. So let's take a look at the screen and see if you got them correct. Rectangle, four right angles, and the diagonals are congruent. In a rhombus, four congruent sides, the diagonals are perpendicular, the diagonals bisect the angle. And then a rectangle has both properties of a rectangle and a rhombus. Let's look at some examples on page 12. So if we look at example number 1 on page 12, we have a rhombus. So that means all four sides are equal. So in this particular problem, we know that 2y plus 3 is equal to 5y minus 6. So the equation we would want to use here is 2y plus 3 is equal to 5y minus 6. Let's subtract 2y from both sides. 3 is equal to 3y minus 6. Add 6. 9 is equal to 3y. Divide by 3. Y is equal to 3. Now we want to find the perimeter, so we need to plug that value back in. So 5 times 3 minus 6 is equal to 9. 2 times 3 plus 3 is equal to 9. So all four sides are going to be 9. So the perimeter is 4 times 9, which is 32. In problem number 2, we have a square. So again, in a square, we know that all four sides are equal. So we know that 5x minus 8 is equal to 3x plus 14. And let's solve that problem. Subtract 3x from both sides. 2x minus 8 is 14. Add 8 to both sides. 2x is 22. Divide by 2. X is equal to 11. Now make sure we substitute back in because we want to find the length of MP. So the length of MP is the same as 3x plus 14. It's also the same as 5x minus 8. So it doesn't matter which one you plug in. So MP is 3 times 11 plus 14, 33 plus 14. And when you add those up, you get 47. If you were to plug in 11 into 5x minus 8, you will get the same answer. Let's take a look at problem number 3. So in problem number 3, I see these yellow tick marks. This tells me that this diagram, or this picture, is a rhombus. It's also stated in the paragraph, but those tick marks do tell me it is a rhombus. So one property of a rhombus is the diagonals are perpendicular. So that means the measure of angle 4 is equal to 90 degrees. Another property of a rhombus is the diagonals bisect the angles. So this green line bisects the angles. So on the left-hand side we have 68 degrees. That means the other side is also 68 degrees. It also means angle 2 is 68 degrees and angle 3 is 68 degrees. So the measure of angle 2 is 68 degrees. The measure of angle 3 is 68 degrees. And then I am missing angle 1. So I'm going to redraw this diagram. And I'm not going to draw in the diagonals. So when I redraw that diagram, if I were to add 68 plus 68, I get 136. So these two angles, without the diagonals, and I'm just going to highlight them here in green, are 136. We know consecutive angles are supplementary. So if I do 180 take away 136, I'm going to write that down. So 180 minus 136, I'm going to get 44 degrees. So at the top left angle is 44 degrees, the bottom right angle is 44 degrees. Now if we go back to the original picture, so I'm going to go erase some of this. If I go back to the original picture, we know, I'm going to outline it here in yellow, we know the large angle is 44 degrees, and since the angle, so this, I'm going to mark it here just for clarity, this big angle here is 44 degrees. The diagonals bisect each other, so the measure of angle 1 is half of 44 degrees, or 22 degrees. Let's take a look at problem number 4. Decide whether the quadrilateral is a parallelogram, rectangle, rhombus, or square. So when I look at this picture, I see 4 equal sides by the blue marks. I see 4 right angles. So because I see 4 right angles and 4 congruent sides, this must be a square. The reason, we have 4 right angles and 4 congruent sides. Let's take a look at problem number 5. So in problem number 5, we are told this parallelogram, or this quadrilateral, is a rhombus. That means all 4 sides are equal. So that tells me 13b minus 9 is equal to 3b plus 4. So we're going to solve that equation. 13b minus 9 is 3b plus 4. We'll subtract 3b from both sides. 10b minus 9 is equal to 4. Add 9 to both sides. 10b is equal to 13. Divide by 10. B is going to be 1.3. Second thing, we want to find A. We know the diagonals in a rhombus are always perpendicular. That tells me this yellow angle that I just highlighted must be 90. So I know 14A plus 20 is equal to 90. We'll subtract 20 from both sides. 14A is 70. Divide by 14, and we get A to be equal to 5. The third part of the question is to find angle VTZ. So I'm going to trace that, VTZ. We know half of the angle is 5A minus 20, and since the diagonals in a rhombus bisect the angle, this other side, I'm going to draw this arrow, is also 5A minus 5. So in order to find the measure of angle VTZ, I need to plug in 5 in for A. So when I do that math, I get 20 degrees. So the measure of angle VTZ is 20 degrees. Let's take a look at example number 6. So we know this is a rhombus. And in a rhombus, we know that it gets all the properties of a quadrilateral. So angle D and angle G are called consecutive angles, and they are supplementary. So that tells me 10x minus 13 plus 7x minus 28 is 180 degrees. Go ahead and pause the screen and solve that problem. So when you solve this equation in blue, the first step is to combine like terms. So you should get 17x minus 41. Then I added 41 to both sides and got 17x is 221. Divide by 17 and I get step 3, x is 13. Now the goal of this problem was to find angle E. We know the opposite angles in a parallelogram are equal. So that tells me angle E is the same as angle G, so 7 times 13, take away 28, so 7 times 13, take away 28, gets me the measure of angle E to be 63 degrees. Let's take a look at page 13. So on page 13, we have some true-false questions. If a quadrilateral is a rectangle, then it is a parallelogram. So on true-false questions, we need to think, does a rectangle have all the properties of a parallelogram? The answer to number 1 is true, because a rectangle has opposite sides being parallel and congruent. A rectangle has consecutive angles are supplementary. A rectangle has opposite angles being congruent. And a rectangle, the diagonals do bisect each other. In problem 2, if a quadrilateral is a parallelogram, is it a rhombus? Well, there are 3 types of parallelograms. Parallelograms could be rectangles, rhombuses, squares, or just a plain parallelogram. So this problem number 2 is false. And a counterexample is, well, maybe the parallelogram is a rectangle. It doesn't have to be a rhombus. Problem number 3. If a quadrilateral is a square, then it is a rhombus. So the question you need to ask yourself is, does every square have the properties of a rhombus? Every square does have the properties of a rhombus. So if a quadrilateral is a square, it is technically a rhombus also. So this is true. Problem 4. If a quadrilateral is a rectangle, then it is a rhombus. Well, rectangles have 4 right angles. Not all rhombuses have, or rhombi technically, have 4 right angles. So this is false. And then question number 5. if a rhombus is a square, then it is a rectangle. So if a rhombus is a square, so a rhombus means it has 4 congruent sides. It's a square, so it has 4 right angles. So if it has 4 right angles, it is a rectangle. So this is true. So I hope you found this useful.